next test, phosphate. PO4 3-, another super important plant nutrient. So these plant nutrients will also cause algae blooms and be involved with eutrophication. So we're going to go ahead and get a water sample here. We fill it up to the 25 milliliter mark. Yes, that's correct. And then we'll add a couple drops of our phosphate activator solution. Okay. Okay, that was a pretty lucky dip. 2 drops. There is 1, 2. Okay. And then we stir it up. I'm just going to shake it. And we'll snap off an ampule in there. These ampules are pretty handy. Invert it a couple times. And we will start our timer for just 2 minutes for our phosphate test. So let's see what we've got. Ideally we have 0 phosphates. Let's see if that's what we actually have in here. And it does look like we are at 0. Okay, 0 phosphates. That's a good indicator of healthy water quality. We're not getting a lot of fertilizer runoff on there, but there's something called turbidity, which we're also going to measure. This is a measure of water clarity or lack of clarity. The higher the number, the more cloudy the water is. So this is from Suspended Solids. Is I have filled this with our water sample, and I put a skeety disc on the bottom of it, that black and white alternating colors. You look straight through the top, and we're going to compare that to, if we're not looking through water, to this comparison. Okay, so we're going to set them right here, side by side, and see which of these matches up the most closely with our view through the water column. And it looks pretty clear to me. I would say that's probably about a probably about 20, maybe 25 JTUs. That's Jackson turbidity units. That's what we measure turbidity in. The higher the number, the less clear the water is. Our next test is of alkalinity. Alkalinity measures the total amount of calcium carbonate in our water. Calcium carbonate acts as a buffer against changes in pH. So we're going to start by getting a water sample, 5 milliliters in this small bottle. We'll rinse it out first to make sure we're in a good place there. And okay, there's our 5 milliliters. I'm going to cap it after I put in just 1 drop of bromophenol blue indicator solution, and this is going to tell us when it hits a particular pH. Okay. So you can see it's turned blue at this point. Okay. And then I'm going to go ahead and take my titration fluid, and I'm going to pull up a full milliliter, actually, full milliliter of titration fluid here. All right, so I'm going to put this in my cap here, and I'm going to insert drop-wise, swirling after each drop, and I'm going to keep doing this until my solution turns yellow. Okay, so no yellow yet, no yellow yet, no yellow yet, no yellow yet. Okay, so there we go. Pretty abrupt change there, and it looks like we have in our syringe, we have pushed out just almost exactly 0.3 milliliters of our titration solution. Okay, 0.3, and we multiply that by 300, 0.3 times 300 to get our total calcium carbonate in parts per million. All right, we're now going to look at hardness, water hardness. Hardness is very similar to alkalinity. Alkalinity measures calcium carbonate. Hardness measures calcium ions and magnesium ions. And this is what makes your water in your house either hard or soft when you take showers. Some places you add water softener to your water if you have high water hardness. So we're going to do a similar process. We'll start with 5 milliliters of our pond water. And to this, we're going to add 5 drops of buffer and 1 drop of calgamite. 1, 2, and 1. And this is our indicator solution, our calgamite. You can see it's changed the color. Okay. And we are going to now, again, run a titration. And we're going to titrate until it turns to a purple and then a blue. Okay, so this is a little bit trickier. Catching it exactly when it turns. You saw how fast it turned last time. It's going to maybe turn even faster this time, okay, with our hardness test. So we're going to do a similar process here. We're going to add dropwise until we get a color change.
So right now it's kind of pinkish magenta. It's going to first turn purplish, and then after like 1 or 2 more drops, it's going to get a blue. Okay, it should be going here pretty soon. We're past our numbers for calcium, so it's got a fair amount of magnesium in addition to the calcium.
Okay, we might be starting to see our first purplish thing here coming up. Getting a little bit darker hue. Okay, there's the purple. And is it going all the way blue? Let's see. It is really close. Probably 1 more drop. There we go. There's our blue. Okay. And that is right here. That is about 0.61 milliliters of our titration solution. And we're again going to multiply that by 300 to get our parts per million of calcium and magnesium ions. So that's parts per million of water hardness. 0.61 times 300. So our last test is one of overall water quality. And we can conduct a freshwater aquatic macroinvertebrate water quality index survey. So we look at what organisms we can find and we determine whether they are very intolerant of pollution. These would be our most sensitive species, a little bit less sensitive, relatively unsensitive, and very tolerant of pollution. So in a very polluted water source, we might find a lot of these kind of things and none of the very intolerant of pollution organisms, and vice versa. If we're in a super high quality aquatic environment, we might find a lot of these and not maybe quite as many of these very tolerant organisms. Okay, and we give them a score. So we have a score sheet here that we're going to keep track. For each species we find, we're going to mark it. Okay, and if we find a damselfly, for example, we put a mark there, and that would be a score of 1, no matter how many we find. If we find a whole bunch of them or only 1, it doesn't matter. We still get a score of 1. If we find all 4, then we have 4 of these. And then we'll multiply it by a weighing factor, and from there we get a total score, and we divide it by the total number of different types of organisms we found. The lower the number, the higher the water quality index, according to this particular index. But there are many indexes you can find. Okay, so we're going to go ahead and get a little dirty and wet and find some critters, hopefully, if it's not too close to winter still. So I've got my nets, got my buckets, and I'm going to go in. They tend to like it in the leaves and the dirt, so we're going to kind of sweep through here, see if we can find anything. And I don't know, it might be too early in the year to find much. We have, that is a piece of leaf. That's old dead leaf. Yes, it might just be too early to find much. Here is a snail. Let's see if it's right-handed or left-handed. And it looks like a, this is a left-handed snail. Okay, so that's like a super tolerant species there. Looks like we're a little too quickly looking at this after winter. The insects haven't had much time to hatch out. We should be finding more than we are, but I'll show you what we did get. So we have here a snail. There are two types of snails. There's right-handed snails and left-handed snails, depending on which direction the spiraling goes. This happens to be a right-handed snail. We found a left-handed snail earlier. And if you can also see in there, we have a worm. It looks to me like a super skinny, segmented worm. An aquatic worm is a group 4, very tolerant, whereas the right-handed snail is a very intolerant group 1. So at this point, I don't think we have enough information to actually come up with a water quality index from this little exploration. We'll have to wait another 3-4 weeks maybe before they're in full array in this lake here. Last but not least is our pH test of acidity and of the water. So this is the easiest test of all, I believe. It's just a simple test strip. So we will dip it in and compare it here. And we dip in for just a couple seconds. Shake it off, and let's see where we're at here. It looks to me like we might be, actually it's like this. It's a little bit higher than a 5, a little bit less than a 6. It looks to me like about a 5.5 for our pH.